All right, so section 13.5 is over factoring binomials. What's the prefix bi mean? 2, okay? So when we use the AC method, it was for trinomials, prefix meaning 3, so it had 3 terms, the ax squared, the bx, the c. But now sometimes we get where we have just 2 terms, and so the AC method's not going to work. So leading up to this, AC method basically could do anything for us. But when we have binomials, there's some special formulas, okay? So the first one's called a difference of squares. How does it happen? It's when the first term's perfectly squared, coefficient and variable, and the second term's perfectly squared, coefficient and variable, and difference means subtraction. What you do is you split the first term. So what's the square root of a squared? You split it to a and a, and you split b squared to b and b, and then you have opposite signs. And we'll kind of talk about why we have opposite signs. 1, positive times a negative gives you a negative, and 2, the positive plus the negative will actually start canceling each other out, so that we lose that middle term. One thing I want to note is there's no such thing as a sum of squares, okay? So sum of squares is prime. A sum of squares is prime, right? So you'll get in this movement of like, oh, I know exactly how to split this up, and then you won't notice that you'll get to a plus sign, and you'll still want to split it up the same way, but it won't work. And again, when we get there, we'll talk about it. The next thing you might see is that we might have cube plus a cube or cube minus a cube. So again, it's a binomial because there's only 2 terms in each. But they're cubed now, so they're to the 3rd power. And how we have it is we have this equation, and what you're going to notice is this formula here matches this formula exactly other than signs. And a hint to remember the signs is the acronym SOAP. S stands for same. What does that mean? This was a plus sign to start with, so this is the same sign, a plus sign. O stands for opposite. The next sign is the opposite sign, right? And AP stands for always positive. So if you go over here, that same thing's going to happen. This is a subtraction, and so the same sign is in the first. Opposite, the opposite of minus is a plus, and this is always positive. Cubics are not very common, and so it's one of those things that I will provide the formula for you every time. So for every quiz, you'll have the formula for you, because it's one of those things that you don't see it that often, so even when you get into higher math classes, you're like, I don't remember it, you'll be able to look that up. Where differences of squares, guys, they're everywhere, and so it's something I do want you to recognize and be able to factor without looking it up, all right? So let's look at these first couple terms. So the first one is x squared minus 25. Do you guys agree that x is squared? Yes. Is that okay? And then what did we square to get 25? What times itself gets you 25? 5, okay? So if you want to follow the formula, and you don't have to do it this way, it's okay. You just say, okay, what did we square to get x squared? X. What did we square to get 25? 5. And the reason why I'm doing that is I'm trying to write it in this a squared minus b squared format, okay? I'm trying to figure out what exactly is my a, what exactly is my b, okay? So what is my a in this case? X. What is my b in this case? 5, all right? So what I do is I actually call it my open arms. Whenever you see a difference of squares, you know you're going to have these open arm parentheses just waiting for you to split it up, okay? So how it works is your a term goes in front. So what times what gives you x squared? X times x, right? We said our a was x. And then what times what gives you 25? 5 times 5, so that's our back number. And then part of the formula, guys, is always opposite signs. Plus, minus, minus, plus, it doesn't matter. Just make sure you have opposite signs. All right? And why this works is because you'll get that x squared term. Maybe x times x will give you x squared. You'll get that minus 25. 5 times negative 5 is negative 25. But what you'll notice is you'll get a negative 5x and a positive 5x that cancel each other out. That middle term's gone. And so instead of a trinomial with a middle term, it's a binomial. So anytime you have a difference of 2 squares, you just split the first term out in front, you split the second term out and back, and have opposite signs. All right? So let's just do the same thing with the middle one, 25y squared. We already know what 25 splits into. What's he split into? 5. And then what will y squared split into? Just y. And like I said, if you don't do this part because you understand how to use the formula, that's fine. I'm just showing you, what did we square to get 25? What did we square to get y? We squared 5y. Okay, that's my A. Minus, what did we square to get 9? 3. And what did we square to get x squared? X. So guess what my B is? 3x. Alright, so my open arms, like I said, if you don't care about this part, be able to do the open arm part. How do you split 25y squared up? 5y, 5y. So 5y will go in front. How do you split 9x squared up? 3x, 3x. So 3x will go in back. And what can't we forget? Opposite signs. Okay? And the whole idea there is 5y times 5y is 25y squared. 5y times negative 3x gives us a negative 15xy, but guess what we turn around and do? Get a positive 15xy. And it cancels itself out. Alright? And then positive times negative gives us a negative 9x squared. Yay. So these are our answers, so I guess I could be boxing them in for you so you know. Alright, so you get here, and a lot of times we freak out as math students when we see fractions. We're like, oh God, how much is a factor of fraction? Well, what's nice about fractions, guys, that if the numerator and the denominator are both perfect squares, you can break up the numerator and the denominator as the square roots, okay? Yes, sorry.
So on one side you do like 2/3?
Exactly. So what do you square to get 4? 2. What do you square to get 9? 3. So what's the square root of 4 9? 2/3. So when we split that second part up, it'll be 2/3 into that, all right? A squared, he's pretty easy. How do we split him up? He's just going to be A, which is kind of weird labeling him A. And then like Randy said, what's the square root of 4? 2. What's the square root of 9? 3. So the square root of 4/9 is actually 2/3. So that will be your B, and that will be your second half. Does everybody see that? And that's all they'll give you. They'll only give you fractions that are perfect squares or perfect tries. No, you know what I mean? Like, that's all. So again, open arms. And when we get further in, guys, I probably won't be doing this. I'll probably just go straight to here. And I'll say, okay, how does A squared split up? A and A, right? And how does 4/9 split up? 2/3, 2/3. And what can't you forget? Opposite signs. You got it. And again, you don't believe me? FOIL it out. 2/3 A and a minus 2/3 A are going to cancel each other out. But what's 2/3 times 2/3? Multiply straight across the top, straight across the bottom, you get 4/9. Okay? Let's look down here. You're like, oh my gosh, what is going on here? There's no numbers. How are we supposed to know what's going on? Well, this is where we have to remember 112, or even if you didn't take 112, like all the rules of exponents, okay? So we know that we want to split something up, and it's squared. So how can you take 4 x's and split them up evenly into 2 groups? How many will be in each group? 2. So x squared is actually how we're going to split x to the 4th up. Does that make sense? Because when you multiply, you add exponents, right? So x squared times x squared gives you x to the 4th. So wherever we see a, x squared is going to go there. And the same thought process goes with y to the 6th. How do we split up 6 things into 2 even groups? How many will be in each group?
I want to say 3, but
it is 3, okay?
Right.
Yeah. So you have y to the 3rd in front, and in the back, and y to the 3rd in the back, okay? Do you guys remember your rules of exponents? Whenever you multiply, you multiply 2 to 2 to the 4th, and 3, y to the 3rd squared is y to the 6th, okay? So when we go to split this up in my open arms way, you just say, okay, how do we split x to the 4th up into 2 chunks evenly? X squared and x squared. How do you split y to the 6th up into 2 chunks evenly? Y to the 3rd, y to the 3rd. And what can't we forget? Opposite signs. Is that all right? And again, you're like, oh, I don't know if I did it right. Just quickly distribute and FOIL. X squared times x squared is x to the 4th. X squared times negative y third gives you that negative x squared y third. Turn around, you get a positive cancel. But last but not least, Positive times a negative gives you a negative, and then when you multiply bases, you add exponents. So y to the third times y to the third is y to the sixth. All right. Looking at this, do you guys agree that x squared is a square and 4 is a square? But what do you notice about the sign in the middle? It's not it's a positive. And way up here, what did I say? There's no such thing as sum of squares. Like, we can't split it up, all right? And you're like, well, I don't believe you. I think we could split it up to x plus 2, x minus 2, right? Well, if you do that and you FOIL it, a positive times a negative gives you a negative 4, not a positive 4. And you're like, okay, well, what if both of them were positive 2's? So you have x plus 2 times x plus 2, but when you FOIL that, you'll get 2x twice, and you'll add it up. So x plus 2 times x plus 2, I'll write it, don't write this down, just real quickly, x plus 2 times x plus 2, you get x squared, great, but then you get 2x and 2x and 4, so you actually get x squared plus 4x plus 4. The only way to get rid of that middle term is to have these opposite signs over here. But the only way to have an opposite signs is when they multiply, they're negative. And that's why a prime, or it's prime. Whenever you have a sum of two squares, guys, you cannot factor it. So you simply write prime, okay? Cannot factor sum. We cannot factor the sum, okay? So that will just be prime. Does that make sense now that you've seen it? Like I said, you'll get in the swing of things and you'll just want to split it up. But if you split it up the way we've been doing this and you FOIL it, you'll get x squared minus 4, not x squared plus 4. There's no way to get that positive 4 at the same time getting rid of our middle term, okay? It just can't happen. All right, over here you're like, hey, Molly, I guess we're starting on cubics because I see x to the cube. Not exactly, because what's the very number one thing you should be doing when you're factoring is looking for a GCF, right? What can we factor out of 4x to the third, 49x? What do they both share? Well, 4 and 49 don't have anything, right? But what variable do they both share? An x. So let's factor an x out in front first. When you do that, guys, we didn't touch any of the coefficients, right? So this is 4, and then how many x's do we have now? You got it, x squared, minus 49, and then now he has no variable, right? So in my math lab, what am I typing right now? That x that I factored out so I didn't forget about it. But we'll just do this real quick so we don't forget about him. And then we'll do our open arms down here right behind him, all right? Because x is part of our final answer, but he's not part of our binomial that we're factoring. All right, let's see if we can do this one without doing our little a squared, b squared, okay? How I do it, as I say, just look at that first term, 4x squared. How can you split the 4 up evenly? How can you split the x squared up evenly? 2 and x. So guess what goes in front? 2x. And then how do you split 49 up evenly? 7. So 7 goes in back. And what do you need? Opposite signs. I'm putting the plus and the minus. You might be a rebel and put the minus and the plus. That's absolutely fine. It's the same thing. So are there any questions on the front page? Not too bad. The thing about this section is, like, when you're doing it, it's not bad. But then when you get all the factoring thrown at you, you forget about them. Because, like, they're almost too easy that you don't practice them as much, and they're not as common. And so when they're thrown at you, you want to do AC method, you're like, I don't know how to do the AC method with it, because you can't, okay? So on the back, what we have here is another thing where it's like, I have no clue what's going on here because nothing looks like a square. The 5's not a square or a cube, but don't forget the number one thing with factoring. You have to look for that GCF. So what can we take out of 80 and 5? A 5, absolutely. So guys, factor that 5 out in front first. And remember, when you factor out a 5, you're just dividing, all right? So we're going to pull that 5 out in front. And then in my calculator, because 80 is a big number. In my calculator, I'm doing 80 divided by 5 to see what it's leaving me with, all right? When you do that, I think you get 16. Does that look right? 16. We didn't touch the y to the 4th, so he's still there. And then what do we need back here as a placeholder to show that that 5 was there at one point? A 1. Is that okay? So then, what I'm typing in my MATLAB, 5, so I don't forget about it. So he's going to be part of my final answer. And I'm going to go do my open arms with him. And the reason why I put him up there, you can put him right behind the 5 too, that's fine. I'll put him down here so we just kind of like what we've been doing, okay? In my open arms, I split him up evenly by squares, not like 16 divided by 2, right? So 16, it splits up square root wise as what? 4. So we're going to have 4. But then why does the 4 split up evenly? Y to the second. So 4y squared, guys, is going to be our first term. Is that all right? And then 1, what's great about 1, it can be a square, it can be a cube, it can be anything for you. So how does 1 split up? 1 and 1. And what can't we forget about? Opposite signs. So you get excited because you're like, okay, this one was kind of difficult. I think I got it. You type it into my MATLAB, and I'll say, although your answer is factored, it's not completely factored. And you're like, what? I took out the 5, I did my AB. What you have to be careful of is whenever you have this higher factor of variable, you might have another difference of squares hiding out, okay? So do you guys remember those, like my grandma had those like Russian nesting dolls, like you pull out and it had like more in it? Sometimes that's what happens with these factoring problems. When your variable's power starts really high, you might factor it, and there's a difference of squares, and you might factor that, and there's a difference of squares. It's like those nesting dolls that you keep taking apart. So, what our final answer is actually going to be is we're going to have a 5. Is that okay? Because he was part of our original. Can we factor a sum of 2 squares? Yeah. Not a sum, right? So the 4y squared plus 1 is all the more that factored that one's going to be. But then what can we do with him? We can factor him again. You guys see that? So like, he himself could have been a problem I gave you. I could have given you that and asked you to factor that. Does that make sense? Okay? So how do we take 4y squared and split him up equally? 2y and 2y. And like I said, how does 1 always split up? 1. And what can't we forget? Opposite signs. And like I said, if this was even a higher power, guess who this could have been? That could be another difference of squares, but it's not, okay? So just kind of like I said, just kind of be leery. Like this high power up here, this might happen, okay? You never factor the sum, so the sum just stays as is, like he kind of just follows along, and then the difference is what you can split up a little bit further.
So if we got this one on the quiz, would you mark it wrong, or would you?
I would give you partial credit. And actually, I think there's one like this on the final, and so it's one of those things where it's worth 5 points. I think I give you 3 of the 5 points if you get the first chunk, and then you miss 2 if you don't get the second. Because you were on the right, that's why I said like, I'm a big cheerleader. You're on the right path, you just stopped a little too soon, okay? This next one is kind of suspicious. And you're like, well, it's a sum, so I'm going to write prime. Well, it's not exactly a sum, because what do you notice right here? A negative. So what happens if we rewrite this as 16 minus 49x squared? 16 minus 49x squared. Is 16 a square? It sure is. Is 49x squared a square? Yeah. And now is it a difference? Yeah. And so what I want you to be aware of, guys, is just because in a lot of the problems, the variables in the front, it doesn't have to be, okay? We're going to split them up exactly the same. We're going to take the square root of 16, he's going to go in front. We're going to take the square root of 49x squared, he's going to go in back, and have those opposite signs. So again, I'm going to do my open arms, if you're okay with that. It doesn't matter where they are, just be consistent with the front goes in the front, the back goes in the back, all right? So what's the square root of 16 that's going to break up evenly into the front? 4 and 4. You got it. And be careful, because again, it's easy to do 2 and 8, you know, if you want to divide, but remember it's the square root. And then how does 49x squared split up? 7x, 7x. And he'll go in back. And then just don't forget opposite signs, okay? So even though most of them are going to have that variable in front, it's okay to have the variable in back, all right? So you don't have to rearrange them unless you have to. All right, so that is it for the difference in sums of squares, all right? Do you have to do this little thing every time? No. I kind of just do the open arms. So, okay, we know difference of squares are going to have these 2 sets of parentheses that we're going to fill in the first part with the square root of the first, and the second part with the square root of the back. All right, so what I need, I almost need two things going on, and I might do that. I'm going to do this where I want you to be able to see it, okay? I'm going to do that so you can still see the formula, but then we're going to do these back ones. I'm going to get creative here, okay? So we've already done these two. We're going to look here, and you get to a point where you're like, okay, it's a sum, but my x is not squared anymore, it's cubed, right? And my 8's not a square, it's actually a perfect cube. And so that's when you know it's going to be one of these special ones, all right? So I am going to kind of do that a, b. So what did we cube to get x cubed? X, you got it. It's not even a trick question, right? X to the third power is x. So that's going to be our a. And why that's important is because now that we know that's our a, in this formula up here, guys, everywhere we see an a, guess what we're going to put? Just x, all right? And then we have plus. We're not as familiar with cubes, but does anybody know what you cube to get 8? It is 2, okay? 8's a pretty small number, and so to cube something, it has to be pretty small. 2 times 2 times 2 is 8. And again, why am I labeling it like that? Because that way in the formula, everywhere you see B, you're going to put a 2. So on these ones, I do this. I label my A, I label my B. I kind of call it the puzzle. Here's the puzzle. We have our pieces. Now we just got to put them in the right spots, all right? Since this is a plus, we're going to use the sum of squares formula. Okay, so we're going to use this right up here. So how does it start? It starts with each one singularly, A plus B. But what is our A and X? What is our B? A 2. So we'll have X plus 2. And this is a big parenthesis chunk. You guys see how I'm just mimicking this up here? So A plus B, X plus 2, all right? Then the second part is A squared. So what do we have? X, and we need to square it. So we're going to have x, and we're going to eventually square it. Do you have to put it in parentheses right now? No. But I'm going to do it because I'll show you sometimes it does make a difference. But x squared is x squared. The reason why I'm putting it in parentheses is because if you had a coefficient, say 2, you got to square the 2 and the x. So it's actually 4x squared, not 2x squared. All right. Opposite sign says the rule. So we're going to have a negative, and then we're going to have a times B. You guys see that? A, B shoved next to each other is multiplication. So I have A times B. And again, a second we'll write it the right way. Okay? Last but not least, always positive is your B squared. What's our B? 2. What do we need to do to it? Square it. And again, I'm putting it in parentheses right now. It's a little shoved. I'm sorry. Because if that was 2y, we have to square the 2 and the y. Alright, so when it comes to cubes, I always set it up like this at first, and then the final answer is kind of cleaning it up, squaring what we can, rearranging stuff if we can, get rid of parentheses. The first chunk will always be the same. There's nothing you can ever do. So that's just going to be x plus 2. But back here, what is x squared? X squared. So we don't really need parentheses, so we're just going to write that as x squared. Minus, typically when we do a variable times a number, the variable goes in the back, right? So we'll write that as 2x. And then what's 2 squared? 4. And you can answer that. One thing to note is this never factors further. The reason I'm noting that is because you guys are going to be like AC maniacs. So anytime you see a trinomial, you're going to want to factor it. And with the cubic formula, guys, once you factor it, it won't factor any further. There's no factors of 4 that add up to -2. You're just going to be done. And what's crazy, guys, this isn't really a FOIL, it's like a distributing property, but if you distribute x to everything in the trinomial and 2 to everything in the trinomial and gather everything, a bunch of stuff cancels, and all that's going to be left is x times x squared, which is x cubed, and then 2 times 4, which is 8. It's weird how it all works out, and it's just this formula, like it doesn't change, it's always going to be that way, okay? Let's look at this next one. I'm going to fold it so you guys can still see the formula up above. Oopsie, sorry. It is another cubic. Do you guys agree that y to the third, y is being cubed? That's going to be my A. Minus means we're going to have to use this difference of square formula over here. I know the clock is kind of showing that. And then what do you cube to get 27? And play around it with it. On your calculator, you can do 2 to the third, 3 to the third, 4 to the third until you get 27. Is that okay? What do you get? What do you have to cube to get 27? 3. It is 3. You guys, you're going to get familiar with 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. I mean, you'll get familiar. Like, you don't need to be, like, you're not, like, at home practicing cards or anything like that. It's just kind of something that you get familiar with. Okay, so what we're going to do, guys, is we're going to use this formula up here. It's exactly like the one we just used, except for the signs are different, okay, because it's a subtraction problem. So up here, it always starts with the singulars A and B with the same sign. So our singular A is Y, our singular B is 3 with the same sign. So we're going to have Y minus 3. Oops, see that? Y minus 3. Okay? Then put really big set of parentheses, a really big set of parentheses. The next part of the formula says take A and square it. So in this case, we're going to take Y and we're going to square it. And again, I'm putting parentheses because the second I don't is when I need them. All right? Then opposite sign is a plus, and then you need A times B. So Y times 3. And last but not least, B squared is always positive, so I put a plus, and B squared is just 3 squared. If you're someone that's pretty comfortable with this, you can go right to the right answer. If you know Y squared is going to be Y squared, 3 squared is going to be 9, you can put it all in and just have that one line, the correct answer. Otherwise, I suggest kind of do like I do, and then clean up as your second line, and that will be your answer, okay? So what we're going to do is we're going to clean this up. The first part, Y minus 3, there will never be anything to clean up. And then the second part, you square things and rearrange. So Y squared is just going to be Y squared. Y times 3 is going to be a positive 3Y. And then we know that 3 squared is what?
27.
Nope, 3 cubed was 27. 3 squared is 9, because it'll just be 3 times 3. And that's your final answer. Okay, and like I said, do you have to do this middle part? No, but I do. I like to just like follow the puzzle first and then clean it up. And so remember, 3 times 9 will get you that 27. Okay, don't make that 27 because that'll be 54 or whatever. It's bigger than 54. All right, guys, we're almost done. This next one is why parentheses are important when we do this part, okay? So you're like, 64, what goes into 64? Again, you do 2 cubes, 8, 3 cubes, 27, 4 cubed is 64, okay? So this is actually 4x cubed, all right? That's your A. Plus, because it's a plus, and then 1 can be anything you want. So how does 1 break up as a cube? As a 1, right? 1 times 1 is 1 times 1 times 1 is 1. All right. So anywhere we see A in our formula up here, guys, we're going to be putting 4x. Anywhere we see B, we're going to be putting a 1. All right. So we have A plus B. The reason why I'm doing plus is because this is a plus sign, so I'm going to use this formula. A plus B, so 4x plus 1. And then my back half has really big parentheses. And I'll do this down here, so I'll have plenty of room, okay? And this is what I was talking about. I need all of A squared, not just the x. So I need to square the 4 and the x, so that's why I'm putting all of A squared like that. If you don't do that, just realize you're squaring both the coefficient and the variable, so you can go right to 16x squared if you want, okay? Minus, because it's opposite sign, A, which is 4x, times B, which is 1. So here's my A times my B, plus my B, which is 1 squared. Okay? So does everybody see the formula? A plus B, A squared minus A times B plus B squared. I'm just following this formula right there. Are there any questions on that? All right, so I'm just going to clean it up. 4x plus 1 will stay 4x plus 1. But guys, like I stressed, what is 4x squared? What's 4x times 4x? 16x squared. So you square both the coefficient and the variable there. All right? 4x times 1 is just 4x, so that's just minus 4x. And then 1 squared is just 1 times 1, or 1. All right, last one. I'm going to write him down here. so we have room. Before we do it, though, I can kind of write the A's stuff up there. All right, I look at this, I'm like, okay, my A's cubed, my B's cubed, but 54 and 16 are not perfect cubes, so what am I supposed to do? What's the number one rule in factoring? What are you supposed to look for? A GCF. So what can you factor out of 54 and 16? My hint to you is, like, what remains you want to be perfect cubes. So take out a 2, because that will leave you with the 27, which is 3 cubed, and the 8, which is 2 cubed, all right? So we're going to take out a 2 first, and we're going to write this as 27a cubed minus 8b cubed, all right? So 2 is going to be part of our final answer. I'm probably typing 2 in my math lab right now, because we're going to do a lot of stuff. I'm going to forget about that too. Then here, let's figure out what our A is and what our B is. What do you cube to get 27? 3. What do you cube to get A cubed? A. So 3A is how we're going to split up that middle, or that first one. So in our formula up here, wherever we see A, 3A is going. What about 8? What do we cube to get 8? 2. And we're going to put a B to follow him, all right? Because 2 times 2 is 8, and B times B times B is B cubed. All right, so my formula down here, I know I'm kind of low, but I want to make sure we still see that guy up there. We're going to follow this formula. A minus B, but in this case that's 3A minus 2B. It's always, I call them singular. It's always then singular, right? It's always what we did when we took a cube root, the 3A, the 2B. The second part, again, kind of look up here, is we're going to square the first term, that goes in front, we're going to square the back term, that goes in back, and we're going to take the product of the two, that's what goes in the middle. But notice both our A term and our B term have a coefficient with it. So when we square it, we got to make sure we square the coefficient and the variable. So I put parentheses around it. So this will be 3A squared, plus sign, because that's what the formula says to do, plus A, which in this case is 3A, times B, which in this case is 2B, plus B squared. So plus 2B squared. I'm getting really shoved in there, I'm sorry. Okay? A minus B, A squared plus A times B plus B squared. At that point, I can't forget this 2. It's going to come all the way down. 3A minus 2B is going to stay as is. And I got to make sure I square both my coefficient and my variable. So I'm going to have, what's that going to be, 9A squared. Here, when you multiply these guys, multiply the numbers first. So 3 times 2 to get 6. And then the variable second, A times B is AB. And in the back, square both, oops, I have the squared on the wrong spot. 2B squared, like that. So that should be what, 4B squared? Can you get all that? I know there's a lot going on there, okay? So the 2 is what we took out in the very beginning. 3A minus 2B were our individuals, A's and B's, so we left them alone. A squared was 3A squared, so we had to square both the 3 to get the 9 and the A to get the A squared. Then we had to take the product 3A times 2B, take 3 times 2 to get 6, A times B to get AB. And then we had to square B, but B was 2B, so we had to square the B, or excuse me, the 2 to get 4, and the B to get B squared. Like I said, they're not horrible. Hopefully, if you can, I'll have the formula for you. You don't have to memorize the formula. The hardest part is going to be figuring out what's your A, what's your B. Are there any questions over these notes? All right, great job, guys.